Example 2. A deer population in a forest is estimated to drop by 7% each year. Each year, 20 deer are introduced into the forest. The initial deer population is 200. Part A, how many deer will there be in the forest after 3 years? And then part B, what is the long-term effect on the deer population? So let's look at part A. So first of all, we want to find out how many deer there will be in the forest after 3 years. So we need to set up a recurrence relation. So we know our initial value, our U0, is going to be 200. We also know there's a drop each year of 7%. So we're starting out with 100% of the value, and we're dropping 7%. So we're getting 93% of the deer population each year. And again, that as a decimal is going to be 0.93. So to get the next term in our sequence, we need to find 93% of our previous value. So we're going to take 0.93 of our current term to find the next term. But we also know that 20 deer are introduced every year, so we're adding an extra 20 deer. So here is our recurrence relation. We also know that U0, our initial value, is 200. So that's the information we have. So we want to find U3, so the population after 3 years. So to get the first year, we're going to take 0.93 and multiply it by my current term of 200. And then we're going to add 20. And that will leave us with 206. We'll repeat for the second year. I'm going to take 0.93. I'm going to multiply it by my current term, which is 206. I'm going to add 20. And I will get 211.58. And then for the third year, I'll repeat. So I'm going to take 0.93, multiply it by my current term, which is 211.58, and then I'll add 20, and I will get 216.7694. Now looking at this, the question said how many deer will there be in the forest after 3 years? Well, we're only going to have 216 deer after 3 years because we're not going to have 0.76 of a deer. So therefore, we'll answer the question with a short statement. So therefore, there are 216 deer after 3 years. Now on to part B. So if we're looking at part B here, what is the long-term effect of the population? So what this question is asking us is what's happening? As we can see with our recurrence relation, the deer numbers are increasing. So is this just going to keep increasing, or is it going to cap off at a certain value? So we want to find if there's a limit, and if so, what is the limit? So let's take a look at our recurrence relation, looking at our A value to help us decide whether there's a limit. So it's 0.93. That is a value between -1 and 1, so a limit does exist. So for part B, a limit exists since A is between -1 and 1. So we have to write that statement. Now we'll use the limit formula. So we know that L is equal to B over 1 minus A. Looking at what our A value is and our B value, our A value comes from the term in front of, or the value in front of UN, so it's 0.93. Our B value is what's added or subtracted on the end, so here we have it's positive 20. We will substitute this in, so 20 over 1 minus 0.93. We're going to get 20 over, when we simplify the denominator, 0.07. And then we work that out, we get 285.7. Now, what's happening here is, again, we're not having 0.7 of a deer. So the number of deer is going to settle at around 285. So we'll just answer this with a statement. So the number of deer will settle at 285.